starting after almost 1 month. So let us get started with a brief recapitulation. So we have been discussing about modeling the
Sir, your
armature
voice
winding.
is bit low, sir.
Is it okay now? Is it okay?
Bit better.
Okay. So we have been discussing on the how on the modeling of armature winding of the DC machine. Previously, we had a long discussion on how should we model the field winding of a machine, and we also realized uh, how to make that model in the MATLAB Simulink. So we have discussed this also. So, but still for a brief recapitulation because we are starting after a long time. So if we consider the armature of a DC motor, and we are here considering a 12 slots, so we are putting 12 coils into that, considering a single layer winding. Now if the rotor is rotated at a constant speed while the field winding is excited, and none of the armature windings are excited, then we saw that flux linkage of all individual coils will be varying with time. So because flux lines are like this, so this coil 1 will be having the maximum flux linkage, whether positive or negative. So for this case this is negative because of the sense of winding only, and our reference direction for flux. That's all. So here it is maximum, and you can see that as the rotor is rotating in the anti-clockwise direction, and as the orange one basically rotates to 90-degree position, that is it reaches the vertical plane, then you can see that, yeah, it actually reaches zero flux linkage, and like that it varies. So similarly all the other coil flux linkages are also phase shifted from that. So we understand that the flux linkage is varying with time with the rotor rotation. So d psi dt is the induced EMF. So we understand that whenever the flux linkage of any coil is varying, then there will be the induced EMF in that coil. So if the slope of flux linkage variation is positive, there will be a positive induced EMF, and if it is negative, it will be negative induced EMF. So we looked at that for different instances. So instant 1 where this coil 1 is in the horizontal position, instant 2 where it goes to the vertical position. We saw that earlier it was here, now it has reached to 0, and similarly it will go on as it moves along the orange waveform as shown there. And flux linkage as an induced EMF, flux linkage of two different coils, because they are shifted in geometry. So say the orange coil and the pink one, they are shifted by 90 degree, 90 degree mechanical. So the electric in the induced EMFs or the flux linkages are also phase shifted from each other by 90 degree, because it's a case of two pole machine. So you can see that coil 1 psi 1 and coil 4 flux linkage psi 4, they are actually phase shifted by 90 degrees. So here where the psi 4 is having its peak, there it is actually having its zero. So and induced EMF, so wherever it is having positive slope, there will be positive induced EMF. Wherever it is having zero slope, there will be some zero slope, zero induced EMF. Again negative slope, negative induced EMF. That is all. Then we discussed about a single layer winding, a possible single layer winding. So we also understood how to decide the number of commutator segments and number of brushes. So number of commutator segment is simply the number of coils that we have. If we have 12 slots in a single layer winding, then we have 6 coils. So we need to have 6 commutator segments. And similarly, if we have if we have a lap winding and two poles, then the number of parallel paths is 2. So we have to put two number of brushes. So here at this instant you can see that I have put one brush one brush is touching the commutator segment 1, another brush is touching commutator segment 4, and this third brush is same as commutator segment 1 only, because it's a circular one. Here I am putting it as linear, so just for the continuity of the coil I had repeated the commutator segment 1 on the right side. So if so we saw that we saw how the currents would be flowing, but we also saw that when the rotor reaches this type of position where the brush is touching two commutator segments, so it means that the commutator segment is, or the brush is basically shorting the coil. So here the coil 3 shown by green, you can see that they are shorted by this brush. So when can we short a coil? If it is having zero induced EMF, then there is no problem, we can easily short that coil. But if it is having some non-zero induced EMF, then it is dangerous to short any coil. So in this case what we discussed is, if you look at the left hand side motor 2D cross sectional view, the coil 3 as shown by green, that is in the interpolar region. The coil 3 is in the interpolar region, and interpolar region coil has zero induced EMF, that we have already seen. So there is no issue if the coil 3 gets shorted by this commutator segment, by this brush touching the commutator segments 3 and 4. But if touching the 1 and 6 commutator segments, that means the coil 6 is being shorted as shown here. So commutator, where is the coil 6? Coil 6 is actually at the uh, polar axis, and at the coil at polar axis has the maximum induced EMF, or whatever the induced EMF. So this is the polar axis. So this is so if I go here, so you can see that orange coil, it is at the polar axis here, and orange coil is having zero flux linkage, but the slope is changing, so positive induced EMF, non-zero induced EMF. So we cannot, but that coil 6 is getting shorted here. So that is the problem with single layer winding. We cannot go for single layer winding for DC machine armature because of this problem. There will be shorting a coil with non-zero induced EMF, and that will be causing some sparking. So we have to go for um, what we call double layer winding. So next we'll be discussing that. So I'll
Sir,
I'll
could you
make a
please
double layer.
move before slide, please?
Okay, you have any question?
Sir, here the coil number 1 is also looking shorted, right?
Coil number 1 is not shorted. Coil number 1 is this red coil. Red coil, the other terminal comes here, commutator segment 2.
Okay. One
It is
red
not
coil
shorted.
starting at 5 and ending at 6.
Yes, that is also not shorted. So that is the next red coil. How to show?
Okay.
You can look at carefully.
Sir,
This is
it would
coil
be better
1.
if you can show us the current path here once.
Okay. Uh, so current path here. So shall I start from this one first? This is straightforward, where one brush is touching one commutator segment only. So say the current is entering from here, then it will go enter through this brush, go to this first commutator segment, this arrow, then it will come back like this. Uh,
Sir, I am unable to see your pointer. Could you please move it once?
okay. So how to? Okay, I have to draw. I have to indicate with some other color. That is the only option, because everything is already drawn. So uh, this is where it is entering. This is where it is entering the current. It is flowing like this. It will come back from here. then it will come here, then this end and this end are shorted in this commutator segment, so the same current will go and flow like this. The blue one, it will come back from here, it will come back here, and commutator segment 3 will short that, and that same current will flow through this green one. Now it will go through this green one, it will come back here, and now all the current, they will be passed, they have completed their path, and that current will complete this path like this. So this is about Ia by 2. So total current is Ia. Among that, Ia by 2, half of that is flowing through this commutator segment 1, and the other half is, because commutator segment 1, that will be touching two coils. So one coil is coil number 1, another coil is coil number 12. So that will go out from coil 12, it will come here, then it will complete its path, come back from here, it will be shorted in commutator segment 6, then it will go here, then to this red one it will come back. This is how it will come back. Then it will be shorted at commutator segment 5, again it will go to the orange one, it will come back to the orange one on the other side, and it will come back here, and that other Ia by 2. So Ia by 2 was coming from this green one, other Ia by 2 is coming from this orange one, both of them will be collected by this brush, and that will be sending the total Ia. So that is about this rotor position where no commutation is happening. But here where commutation is happening, then you can see that uh, okay, so this one is actually not a physical case, because that is not practical. We cannot do this because we are one coil with having induced EMF, some non-zero induced EMF, we are shorting it. So it may not be physical to look at the current path in this case, but I will be discussing the current path for the shorting case also when I go towards the double layer winding. So probably I can go to the double layer winding, because it's not physical, right? You got it right. It is not a practical case. For conceptual understanding only I am discussing this, that okay, why can we not go for single layer winding in a DC motor? That's all. Because of this problem, that where during commutation one of the coils will be having non-zero induced EMF, other coil will be having zero induced EMF. So this coil 6, because coil 6 is being shorted, the blue one, this coil 6 is being shorted, so it will be having large circulating current and lot of sparking, so it is not a practical one. So let us start with double layer winding. So what do you mean by double layer winding? Double layer winding, each slot will be there will be two conductors in each slot. So that is so one coil will be on the top of the slot, another coil side will be on the bottom of the slot. So here let me first indicate the slots. So this black straight line, they indicate the slots. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. After that I have to come back to 1, 2, 3, 4. Will it be sufficient? Don't think so. To erase some of them. Okay, so these are the slot numbers. 1 2 3 4 5 6 7 8 9 10 11 12 up to 12. So because it's circular one, for the completeness, because I'll need them while drawing the coils, I'm indicating up to, I'm repeating the other ones also, like 1 2 3 4 5 6 also I'm repeating. Now I will draw the commutator segments. Here how many commutator segments will you need, because it is a double layer winding and we have 12 slots, so we will have 12 number of coils, so we will need 12 commutator segments also. So probably I'll start from here. 12 commutator segments.
Sir, is there any relation between number of commutator slots and the coils?
Yes, number of
Okay.
slots and what how so I have discussed this before also. If you have, say, 12 number of slots, and if you have double layer winding,
It will
then
be 24
how
conductors and will have
24 conductors.
12 coils.
Yes, that is all. So we need to make 12 ones, 12. So 4 divided into 3. So these are the 1 2 3 4 5 6 7 8 9 10 11 12. So these are the commutator segments.
Sir, is there any relation between the number of coils and the y exactly equal to coils, sir? Commutator segments equal to, is there any reason?
Because we have to connect everything, every coil to one segment. Every coil should start with one segment. That's all.
Okay. Um, that means, sir, each turn has runner, run long, some kind of thing. Go
I
around,
did
go.
not get you. I did not get you. Please repeat.
What I'm saying is, suppose we think we have one coil.
Yes.
The end of coil must be the start of another coil. Is that the
Yes.
case?
Yes.
Okay, okay,
So
got
each
it.
coil has to start from one commutator segment, and end at some other commutator segment. And each commutator segment should be start of one coil and end of another coil. That is right.
Okay, okay, sir.
Yeah. So I'll start with, so the convention is like this. If I draw a coil on the left hand side of the slot, you consider that it is the top conductor, and if it is at the bottom, then you consider, if it is on the right hand side, then you consider it as the bottom conductor. Okay, once I start, it will get clearer. So let us start from segment number 1. So let us say it goes like this. it I'm drawing it on the left of the first coil, so that means it is the bottom, it is the top conductor, right? Probably I'll make it little shorter to correctly draw the overhang. Okay, so the red one, so if so it has come and sat here, so the opposite one will be coming from the diametrically opposite one, that is seventh bottom. So I have to take it to the seventh bottom. Yes, seventh bottom. You come back and it will be connected to segment number 2. So this is our one coil. Is it clear? The it is from segment 1, it is going to the top slot, top position in slot number 1. It is coming back to the diametrically opposite slot number 7, but it is it is put in the bottom place in slot number 7, and it is coming back and getting connected to segment number 2. It is clear, right?
Sir, why
uh,
cannot be the other way? Top, why cannot it start at the bottom and end at the bottom? Is there any?
no, nothing, it's about convention.
Sorry, sir.
You can do that, there is no issue.
Okay, okay.
There is no issue. Actually, you could when you are making winding, you have to first put the bottom one.
Yes,
Otherwise,
yes.
if you put something on the top, then you cannot insert something later on. So
Yes, sir. But what I have observed in an industry is they actually they are keeping some conductors, and later on they are using some copper and using brazing technique, kind of
yeah,
welding with copper.
so finally you have to one slot you have to, when you are making winding, then you have to keep, you have to because say you are starting with coil 1, one side should be at top, another side should be at the bottom. Say you place the bottom one, but can you place the top one first? No, you have to keep it outside only. Only after you have your bottom one is put, then only you can put. That's all. uh, I'm not sure what you told about brazing, but yeah,
Huh.
there
What
will be
I'm saying
some
is,
industries will be doing some technique to complete this procedure. Yeah,
yes, sir. What I'm saying is, as you are saying, for keeping a coil,
yeah,
we need first the bottom conductor, then only we can place the top conductor. You are saying that's, I
correct.
agree with you. But
Yes,
what my point is, in an industry, actually, they are not using exactly the turns what we think of. They're actually placing some copper bars in the rotor slots, and later they are using some kind of welding with the help of copper to make the
yes,
turns. To
yes.
connect one conductor with the other conductor in another slot to form a coil.
Okay, that
Yes,
is also, that must be a quite high power machine, a big
yes, yes,
machine where, yeah,
yes, sir, exactly.
for
But
that it is the case.
what my thinking is, uh, to form a coil in case of double layer winding, why the one is on the top and the another is at the bottom? You are saying in the slot 1 and 7. Why cannot be both? The coil one has lower conductor, bottom conductor in both the slots.
You do it physically, you wind one machine, you will understand that physically it is not possible.
Okay.
Physically it is not possible. Once you wind a machine, then you will realize it is very difficult to explain.
Okay, sir.
You
Okay.
will, the overhang will collide with each other. So it is only this overhang portion will also have to
Overhanging,
come,
sir.
right?
Yes, 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 yes.
So unless one is at the top and there is at the bottom, then you will find if you want to keep both on the top, both on the bottom, then overhang will not have any
Yes, sir. The
space.
length of overhang will be different, right?
Yes, that will be increasing as you are putting more coils.
Yes. For one coil it will be higher, and the other coil it will be lower, right?
Yes, yes,
Which is not desired.
yes.
Okay, sir. Got it. Thank you.
Okay. So let us start from the second coil. So second coil will start from at commutator segment 2. It will go there on the top, complete its path like this, come back from each slot, it will come to segment 3. Then let me go to the next one. Next one goes like this. Same business. Orange one, same segment, right? Then again red. After red I have used blue. So it has come to 12 slot, then again 7 coil goes to 7 slot top, first slot bottom, it comes back to 8, then from 8 it goes to segment slot number 8 top like this, then 2 comes back to segment number 9. Next is orange is completed, again red, come back to 10, from 10 you go to slot number 10 top, come back through 4 bottom, come to segment number 11, then green one, 11th this one, go there, 5, come back through 12, another one is remaining, 12 coil, if you go, 6 slot, it will come back to segment number 1. I have to put that segment number 1, right? So this is your double layer winding for the armature. Now we have to put the brush. So here the brush position will be like this, one brush will be touching the segment number 1, another one will be touching segment number 7. So I have to put another one here. So this is your one connection, and this is where another connection. These two brushes are the same, so physically I should be putting this one to indicate that both are same. So this is one terminal of the armature coil, another terminal of the armature coil. So say some current, I have not indicated the current direction, so let me define. So say this is the current direction here, so it should come out, the entire current should come out like this from here. Now what about the direction? So from here it will enter, so half the current, so say total current is Ia, zero point 0.5 of Ia will be entering through this path, and another 0.5 will be coming and entering through this path, because it's you will find that these will form two parallel paths. So that is what you mean by parallel path in a DC machine, because we are using lap winding. We see that parallel path is equal to the number of poles we have, and we are winding it for two poles, so we have two parallel paths, and this total current will again have to be Ia, and total Ia will be coming out from here only, because both the coils are connected, are shown here in the same place, so there is no um, problem of showing the two brushes in two locations like the other brush. So let us start here. Ia by 2 will enter and flow like this, it will come back and flow like this is the red one, then it will come back to the segment 2. Here it is shorted, no other brush is connected, so it will come and go like this, and again to the blue one it will come back like this. Here segment 3, they are shorted, the two coil sides, they will come here, then green one, it will complete its path through slot number 9, it will come back to segment 4, segment 4 it will pass to coil number 4, it will be flowing like this to coil number 4, from slot 4 to slot 10. Here it will be downward, Again commutator segment number 5, again red, it will be flowing upward. From 5 it will be flowing downward, and again segment number 6, from there it will be flowing to slot number coil number 6, that's slot 6. It will be coming out like this, slot number 12. Here it comes back to segment number 5, and half of the current has come back. Now let us trace the other half of the current. So other half is flowing uh, to the other coil, the orange one. So it will be flowing like this upward. So 6 is nothing but here. So 6, this coil, orange coil, is actually same as this only. 6 slot, 6 slot bottom, this is, there is no difference. So you find that here also it is upward, here also it is upward, the current direction. So in one slot the current direction is always either upward or downward. So 6, the orange one, comes back like this, here it is downward. So you see that slot number 12, both the coils are flowing are carrying current in the downward direction. Now it comes back to segment number 12, it goes upward like this, comes back downward like this. Again segment number 11 goes up like this, blue one comes down like this to the blue one, then transfers to the red one, goes up like this to the red one, comes down like this. Now from segment number 9 to the orange one, goes up like this, orange one goes down like this. Now segment number 8, transfer to the green one, goes up like this and comes back to the green one like this and gets collected at the segment number 7, and they are coming out, the intercurrent is coming out from here. So you can see that segment slot number 1, 2, 3, 4, 5, 6 are carrying current on the upward direction. So if they are dot, the entire slot will be dot only. If it is cross, the entire slot will be cross only. And the other slots like 7, 8, 9, 10, 11, 12, whatever is the direction of the other slots, the opposite direction of current flows to the other slots, right? So this is how the current flows for at this rotor position. Uh, there is no commutation, basically the brush is touching only one commutator segment, so no coil is being shorted, so there is no problem. But the next one, the same picture I have drawn previously only, so that we do not lose any time. So here you can see that our slot number 1 was here, the with red one I had indicated here. Now the rotor has actually moved in the anti-clockwise direction. So slot has come here, the red one has come here, the coil 1 has come here. So this is the new rotor position, and actually you can see that the 6 slot and the 12 slot, they are exactly at the magnetic neutral axis, right? So here what is moving? The rotor along with the armature, they are moving in the anti-clockwise direction. That is, this the commutator segments and the coils, the brush location remains fixed from the earlier location. This entire thing, this coils and the commutator, they are moving in the right hand side direction. So if the commutator, if the this thing moves in the right hand side direction like this, then you can find that uh, the brush at 7, after some time it will be touching 6 and 7, and the brush at 1, which was touching 1, that will be touching 1 and 12, right? This is what you see here. One brush is touching 1 and 12, another brush is touching 6 and 7. Now what happens here? Now let us try to look at the current direction in this case, so that we have idea what happens during commutation. So let me select left one only. So now what I will do, I will only, okay, so the same one, the brush, say this brush, which what the brush uh, which was connected to commutator 1, that was having inward current. So this brush must be having 1 and 12, this brush must be having inward current. So this is the inward current IA. So half of that flows through this one coil for coil 1, another half is flowing through uh, the other coil. So how it will flow? So we can say that the 12th coil and the 6th coil, they should not be having any current. The 12th coil and the 6th coil, they will not be having any current. So that means this current, whatever current is coming to segment number 1, that will be that will not be or that will not be going to coil, this orange coil, that is coil number 12, but the entire thing will be passing through this red coil, that is the coil number 1. So entire current is flowing through this, it will come back to this red one, it will come back here, it will get shorted in the second one. Here it is the same, so I will do it quickly. To the blue one it will come back, to the green one it will go, green one it will come back, it will go to the orange one, it will go up, orange one it will come back here, then it will again get transferred to the red one, it will come back to the red one, and it has come back, come back to the sixth commutator segment, and that is collected through this brush. What is the other IA by 2? Other IA by 2 is actually here. So obviously it cannot it should not go to coil number 12, the orange one, because it is shorted. So the current will flow through this green one, it will go up, through the green one it will come back again. You see that 11
Sir,
slot.
sorry, could you please repeat? The current is entering from the one, right? B1,
Yes,
in the right hand side.
yes,
Yes, from there, why you are not showing in the sixth slot?
not showing in the sixth slot. What do you mean?
Uh,
Sixth,
rightmost orange coil.
rightmost orange, yeah, it is okay. Orange coil is the 12th coil, that is shorted,
Yes, correct.
with zero induced EMF, so no current will flow there. That is that coil is going through commutation. That coil is going through commutation, so no current will flow through that.
Okay,
We'll discuss the commutation phenomena again. So there we'll find how the current transfer is being happening. So you will see that as soon as the starts to touch two commutator segments, one of the coil current has to come down and another coil current uh, will be uh, will be increasing. That's what will be
okay,
happening. So
okay,
because it is shorted and it is having zero induced EMF, so the current will not flow through that. Even if it flows through, we'll see that it will be circulating. So some small amount of current will be circulating. Some Nothing will be so even if some small amount of current flows through there, it will be circulating on its own. It will not be coming out to brush or contributing to this current, this IA by 2. It will not be contributing to that because it is a short coil. So whatever current flows, that will be circulating there. It will not come out from this coil, so it will not be contributing to the brush current. That's all. Okay, so this current is here, so it has to flow to this green one only. So this green one, it will come back here, from green to blue it will get transferred, then it will come back to this blue one, then it will get transferred to this red one, it will come back through this red one, it will go through this orange one, it will come back from this orange one, go to this green one, come back through this green one, and it has reached uh, commutator segment 7, where you have some brush connection, so that will be collected by the brush and that will flow there. So we have traced the current paths. So you can see that the coil number 6, that is this blue one, that is not having any current, and the coil number 12, that is this orange one, that is also not having current. So that is why you have this both coil sides at slots 6 and 7, 6 and 12, they are not carrying any current because they are at the magnetic neutral axis and they are going through commutation. So this is the magnetic neutral axis. All the coils which are there on the top, they will carry current of a particular polarity, and all the currents of the bottom will carry current of the opposite polarity. That is what we with that we started our discussion of DC machine, that if we want to have our two magnetic fields perpendicular to each other, then we need to have this stator magnetic field will be perpendicular. Although the rotor is rotating, the rotor magnetic field direction should not change. It has to be vertical. It has to be vertical to that stator magnetic field. So this commutator and brush arrangement ensures that whichever coil comes to this magnetic neutral axis, the current polarity through those coils basically reverse. So earlier, when at this rotor, at this position, this coils at slot 12, they were carrying current in the cross, or 12 means they were carrying current on the downward direction. Now they are not carrying any current. Now as I go to the next rotor position, where the rotor has rotated little bit more in the anti-clockwise direction, so that now the brush B2, which was in contact with commutator segment 6 and 7, now it is in contact with only 6, and the segment which was in contact with 1 and 12, that is now in contact with only 12. Now we have the total current IA that will be distributed to the two coils connected to this brush, connected to this commutator segment number 12. So let us start with this green one. It will go up to green one, it will come back. So green to blue, up, blue bottom, blue to red, up, red bottom, red to orange, up, orange bottom, orange to green, up, green bottom, or green to blue, up, blue bottom. So this gets collected by this brush, and the other component of current, that is here, it will be going through this orange one. So again it will be upward, so
Sir,
it will
sorry to
come
interrupt
down.
you. Could you please repeat that point once?
Which point?
Just now you have mentioned one path, right?
Okay,
Till B2
so
it is clear, sir.
till B2
One
is
came,
clear.
yes, sir.
Okay,
From blue of sixth slot you have, and some current came. That's clear.
okay. So B1, so total current is IA. B1 has two coils connected. One is the coil 12, the orange one. Another coil is coil this green one, that is that is actually coil number 11, right? This green one. There are two coils connected to this 12th one. So the current will get equally distributed by this through these two paths. One current, the path that I have already shown is the current that flowed like this. So total current IA is coming here, IA by 2 is going there, another IA by 2 will be going to this orange one. That path I have indicated now. So this orange one, it will come back to 6 and it will go to segment 1. This one and this one, they are non-different. So whatever current comes like this to 1, this one will come from this segment 1 on the other side. Now it will complete bottom, red to blue, blue to blue bottom, now blue to green, green bottom, green to orange, orange bottom, orange to red, red, then red bottom, then this red current is coming and that will get collected by this brush. So one component of current is coming from here, that is 1 IA by 2, another component of current is coming from there. So they will get collected by this commutator segment and sent to this brush. So another IA, right? So you can see that for this case 12 12 is also, slot number 12 is carrying current on the upward direction. So 12, 1, 2, 1, 2, 3, 4, 5. 12, 1, 2, 3, 4, 5. They are carrying current in the upward direction, say dot, and so 11, 10, 9, 8, 7, 6, they are carrying current in the opposite direction, but downward direction. So here we will have to indicate cross. So here again you see this is the magnetic neutral axis. All the coils on the upper side, they are carrying dot polarity of current, and all the coils on the bottom side, they are carrying cross polarity of current. That is what we needed. Now if you see what is happening to this coil 6, say, let us say what is happening to coil number 6. Which one are we just discussing? Yeah, coil number 6 only. What is happening to this coil number 6? Earlier here, this coil number 6, that is this coil, so coil number 6, you can see that it is carrying current upward direction. So here it is dot. 6 means the top coil, right? Here it is carrying upward direction, current in the upward direction. Maybe let me indicate with one another color. Let us see here, this one. So this is our coil 6 that is carrying current in the upward direction. If we go next, what is happening there at coil 6? There is no current, right? The next rotor position. What is happening next? This is our coil 6. This is carrying current in the downward direction. So what happened there? Here our coil 6 was, this is our coil 6. This is our coil 6. Here it is current, carrying current, the dot polarity here in the upward direction. Next the coil 6, next the coil 6 changing. Now the 6 has come here in the magnetic neutral axis, so it is going through commutation. Commutation means it is reversing its polarity of current. So for reversing from positive to negative, it needs to reduce in a reduce uh, continuously. It cannot drastically reduce. So here at this rotor position it is carrying zero current. In the next rotor position where 6 has come here, you can see that the current polarity has reversed. Now it is carrying current in the downward direction, which means here cross direction. Similarly, if you look at what is happening to this 12th one, the 12th one, where is the 12th one? So this is the 12th one. Here it is carrying current in the downward direction, so cross here. Next, the 12th one has come to the magnetic neutral axis. The 12th one, it is not carrying any current. Now again, if I go to this 12th one for the next rotor position, the current has changed its polarity to upward direction, so it is here dot. So for these three rotor positions, what I have shown, the commutators, commutator arrangement and the brush connections, the coil number 6 and coil number 12, they are actually, or the coils which are located in slot number 6 and 12, they are undergoing commutation, because from this rotor position, considering the rotor to be rotating in the anti-clockwise direction, this 12th one and the 6th one, they are approaching the magnetic neutral axis. They reach the magnetic neutral axis and then they pass through the magnetic neutral axis and go to the other side of the uh, magnetic neutral axis. So the current polarity has changed. Is it clear? Do you have any question? Does anyone have any question regarding this?
It's clear, sir.
Okay. So let me show you exactly how, what is happening uh, during the commutation uh, periods. So quickly I'll draw a simplified diagram. So say this is the commutator segments, say this is 7. For the first one, the brush was placed at 7. So I'll be focusing on the 6th coil commutation only. So this is the 6th one, this is the 8th one, this is the 5th one. So this much is enough. 4th one, this is 9th one. That's all. Now I will draw the coils. So there are two coil sides. This is one end, this is another end. These are the two ends of the coil sides, right? So say 7, from 7. So this is the coil and it's coming to 8. So this is one coil. What about the 6th coil? This is the 6th coil, right? What about the 8th coil? This is the 8th coil. This is the 9th coil. Just to indicate a few more, this is this coil. I think this much is enough. Okay, so now we saw that entire current was coming out from here. If this is IA, what should be the path? Or this IA has to come to here. So that means these two are anyway
Half is
connected,
coming, half is
and
coming from sixth
this whole
coil.
thing, yes, this whole thing is connected to the is accessible to the through this brush. These are also connected, but you can see that there is no brush connection to take away the current out to the external world. So half of the current is coming from the seventh one, and another half is coming from the sixth one, like this. And before that, this current was obviously coming like this, and it was coming like this. So from here it is shorting, it is coming like this, it is coming like this, it is getting collected, and again from here, say, this is coming like this, shorted by this segment, say 6, coming like this, and again collected there. So this is our coil 6. This one is our coil 6, which is having current in this direction. This is our coil 7, which is having current in the opposite direction. And brush is collecting the two currents like that. Now the rotor is rotating in this direction. So the commutator segment along with the coils, they are going in the right hand side direction. So the brush locations are stationary, brushes are stationary, they are not rotating. That means if the whole thing rotates, then the brush will come back here after some time. So what will happen there? Let me indicate that. So the brush location remains the same, but now it touches two things. So the seventh one goes forward, sixth one remains here. Then you have the fifth one, you have the fourth one, again you have the eighth one, you have the ninth one. If you want, you have the 10th one. Now the coils, they remain the same. These are the two terminals of the coils. The connection also remains the same. So seventh one I do like that, eighth one do shorter, ninth one further shorter to 10, then sixth one do like this. Oh, I did a mistake.
Yes, sir, it's not wrong. Correct.
Right, so sixth one will be connected here, seventh one, this is 7, 8, 9. So the seventh one will be coming here, the eighth one will be going there, the ninth one will be going there to the 10th one, right? And from the fifth one to the sixth one, right? So which one is our coil 6? So this is our coil 6. This is our 5, this is our 7, or no, sorry, this is our 7, this is our 5, and like that. Now how the current will flow? Now this is our current. This
Sixth
entire
coil
IA
has
has to
zero
flow.
current,
Yes.
and the current will come from 5, half of the current, and half of the current will come from seventh coil.
Okay. So even before that, just when it starts touching, just now, so till now, coil 6 is carrying current like this. Coil 7 is carrying current like this. Now, as it starts touching the sixth one and seventh one, what will happen? Say one of the currents will reduce, another current will increase, right? So this fifth one, say okay. So before that, this is coil 5. So coil 5 current should not change, it should not change at all. So coil 5 current will be coming as it is, and uh, zero point 0.5 current is already coming here, right? And the brush is now connected to all these terminals. So all these four terminals are sourcing the entire current IA. Now what needs to happen? This is 0.5 IA. This is anyway coming, and this one, the coil 8, this is also not going through under commutation. So this zero point 0.5 will also come, it will flow. So the seventh coil is also having 0.5 IA, and that 0.5 IA is coming here, right? So this coil terminal current will not change. Now just before commutation, coil 5 was carrying current in this direction, 0.5 IA, and so it will start reducing, it will start reducing, uh, it will start reducing, and another one will start increasing, that's all. So this zero point 0.5 and 0.5, this remains fixed. Am I missing something here?
Sir, it would be better if you can show it through a graph. I think it would be better.
I think so. If I show using a timing diagram or waveform, which the individual coil currents, that will be better. So let us say this is current. So coil 6 earlier was carrying total IA by 2, right? Coil 6 is carrying IA by 2. Okay, probably I'll look at that once more. Probably I'm missing some trick, only some drawing mistake or something is there, that is why I'm missing that trick. So I'll discuss it later, the computation example. I'll just discuss how the flux linkages for the double layer armature coils will be. Actually they will be of no difference compared to the single layer case, because for the double layer case the only difference is we have this entire single layer coil is being divided into two portions, that's all. So the all the individual flux linkages of coil, so one is the top one, that is our assumption here. 1 2 3 4 5 6, this will be 7 8 9 10 11 12. So these are our 12 coils, and the flux linkages, as the field is excited and the rotor is rotated in the anti-clockwise direction, the flux linkage shapes will be same. So 1 and 7, they will be of the same shape, or the same flux linkages for the first coil and seventh coil. So this 1 and 7, I can write 1 comma 7, 2 comma 8, 3 comma 9, 4 comma 10, 5 comma 11, and 6 comma 12. Only thing, because if single layer had say 10 turns total, now it has 5 turn, so the individual numbers will be divided by 2. So instead of 0.2 it will be 0.1, and instead of minus 0.2 it will be minus 0.1. The flux linkage waveforms will be remaining the same compared to the single layer case, because now if we have the total number of turns to be the same in a slot, and instead of one coil we divide it into two coils, then obviously the flux linkage, because the number of turns is getting to half, then the flux link for the same flux, the flux linkage will be also becoming half. And 1 and 7 will have the same flux linkage, same about 2, 8, 3, 9, 4, 10, 5, 11, and 6, 12. Now what about the net induced EMF? Now let us go and see the net induced EMF. Which one should we discuss? So for this case, I will be erasing a few. Discard something that will take away all the unnecessary stuff. I'll be coming back to here. So for this one, you saw that these coils, coil basically coil 1 or the coils in slot number 1, 2, 3, 4 and 5, they were carrying current in the same polarity and they were actually in series. If you see, this was one of the starting point. This was one of the starting point. So it came like this. So this is our coil 1, it ended here, and our coils 2 started here. So it is like coil 1 is like this, and immediately after there is coil 2, and they are connected in series. So coil 1, coil 2, coil 3, coil 4 and coil 5, they are connected in series for this rotor position. So the induced EMF of these individual coils, they will get added up while considering the induced EMF of the coil of that entire phase. So entire armature winding, two terminals are these two ones. So these two ones include two parallel paths. One is this path 1 to 7. This is one parallel path. Another parallel path is this one 12 to again 6 or 7, whichever. There are two parallel paths, and within each parallel path there are 1, 2, 3, 4, 5 coils coming in series. So whatever is the induced EMFs of these 5 coils, they will get added up and visible as the induced EMF of the entire armature coil. I hope that is clear. Now let us what will be the induced EMF of these 5 coils? We saw earlier that if any coil is under the pole, then its flux linkage is actually increasing. If any coil is in the magnetic neutral axis, its flux linkage is either positive maximum or negative maximum, and it is constant. So there is no change. So you can see that this coil 1, that is at the magnetic neutral axis, its flux linkage is constant, there is no change. So induced EMF is 0. Again here induced EMF is 0. But when a coil is in the uh, under any pole, say for 2, you can see 2 at 0 location is here, it is rising. 3 is also rising here, 4 is also rising, 5 is also rising, 6 has just stopped rising, and hence after that it becomes almost stationary. So whatever are the induced EMFs of these 5 coils, they will get added up and will be reflected as the induced EMF of the entire armature coil. So say if this slope, all these are almost straight lines of equal slopes. So say if say 10 volt per coil is the induced EMF, so the entire induced EMF will be 1, 2, 3, 4, 5. 5 into 10, that is 50 volt. That's all. Now next, after some time when actually the coils are in position 3 like this, then 12, 1, 2, 3, 4 coils. But you can see this 12 and 5, they are not under the pole. That means their flux linkages are reasonably stationary, so they will not contribute to the induced EMF generation. But this 1, 2, 3 and 4, their flux linkages are changing, and they will contribute, they will have some induced EMF. So if I go to this one, after some time, where this one will not have any induced EMF, but the other ones will have some induced EMF. Say all are rising, you can see at this instant, this is rising 2, 3, 4. 4 are rising, but the fifth one is not rising. So in this case, you have 4 coils which are actively participating to induced EMF production, and they are connected in series. So if the same thing, 10 volt for coil, so 4 into 10, that will come out as 40 volt. So as the rotor will be rotating, you can only have 3 rotor positions. The first one being like this, where 1, 2, 3, 4, 5, 6, they are coming in series, but effectively only 2, 3, 4, 5, they are having induced EMF, so 40 volt. Next one, 2, 3, 4, 5, they are coming in series. 12 and 6, they are going through commutation, they are shorted, they are not part of this series path. So 4 and all 4 or all 5 are actively participating in induced EMF production, so 50 volt. Then again come back to the original first position only the difference being now 12, 1, 2, 3, 4, 5, they are coming in series, and out of them 1, 2, 3 and 4, they are actively, they are having non-zero induced EMF, so again 40 volt. So as the rotor will be rotating, the induced EMF for this case at least will be pulsating between 40 volt and 50 volt. As you will be increasing the number of slots, so this region, this difference, this jump, basically the voltage per coil will reduce, and along with that, it is possible to show, probably I'll show here only. Say this is our stator pole. Say this is our rotor. Say we have many coils. Say we have many coils here. So this is our magnetic neutral axis. Say we have many coils: 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Here I have made almost 18 coils under one pole. So you can see that all these coils are participating actively in the induced EMF production, but these coils are having very zero induced EMF. So even if you go to the first thing is the commutation. So one of these coils will be shorted, and already they are in vicinity of the magnetic neutral axis. The induced EMF participation or the contribution of these coils is very low, because already they are in a magnetic neutral axis. So the ripple earlier, the ripple which was between 40 volt and 50 volt, which was almost 20%, now because the coils going through commutation are already contributing to very low induced EMFs, so the ripple will be quite low. The ripple due to rotation, the ripple in induced EMF will be quite low, and that can be reasonably approximated as a DC quantity. So we see that although that induced EMFs of individual coils, they are quasi-square wave like this. So positive in some region, zero in some region, again negative in some region, but due to the commutator and brush arrangement and their interconnections, due to that, and if we ensure high enough number of coils by putting more number of slots, then the net induced EMF reflected, or that is reflected across the two terminals of the brush, that is reasonably a DC value with negligible ripple. So although the induced EMF of individual coils, so E1, E2, E3, all the individual coils, they are quasi-square in nature, quasi-squared in nature, but net induced EMF EB across the two brush terminals, they are reasonably DC with negligible ripple. So that concludes that why do we have a constant DC induced EMF in a DC motor. So we have, although we have quasi-square wave induced EMF waveforms in the different coils, we have DC induced EMF. So now if we want to model the armature coil, we are sure that we need to put some induced EMF, which is EB, which obviously is dependent on the speed, but we need to have that. Along with that, we need to put the resistance of the coil and also the inductance of the coil. We'll see why the inductance is a constant value inductance or a variable value inductance. We'll see that, because as we can see, as we have understood before also, if we look at one individual coil inductance, so say this coil 1, coil 1, this is having a reasonably high permeable path, so its inductance is quite, reluctance is quite low, so inductance is quite high. But when the same coil comes here, then it's along its axis there is larger air path, so the reluctance is quite low, so the inductance or sorry, reluctance is quite high, so inductance is quite low. So the individual coil inductances vary with rotor position, but in the equivalent circuit of the armature coil, will it remain a constant value inductance, or a rotor position dependent inductance? That you will see on the next day after a brief discussion on the commutation that I have not completed today. Okay. So, do you have any question? Any question? Why the induced EMF becomes a constant DC quantity? Is it clear?
Sir, that is the point. A bit tricky to understand, it seems, sir.
Okay. So, okay. Next day I'll again reiterate it once more.
Okay, sir. Thank you so much. Actually, we are clear that it will be quasi-square wave. Quasi-square wave. It is clear, sir.
Mm.
But you are
The
saying,
individual induced EMF, they are quasi square wave. That is clear, right?
yes, sir. That is clear.
Okay.
But you are
Now,
saying some kind of parallel paths, and they get added. It's a bit confusing.
okay, why are they coming in series? Is that not clear?
Yes, sir, that is also clear. They are in series because of the winding connection itself. Why?
Yes.
Because on the commutator, the end of one coil is the start of another coil. They are in series.
Result.
That's part is also
Yes.
clear, sir.
Yes. So
But when we,
for an example here, if I consider from segment 1, this is one coil.
yes, sir,
This is
they are
coil
in
number
series.
1.
Sir,
This is
they
in
are in
series to
series. That
coil 2.
yes,
This
this
is in
point is
series to
clear,
coil
sir.
3. This is clear, right? So finally
Yes,
it is
yes.
like coil 1, coil 2, coil 3, coil 4. coil 5, coil 6.
Yes,
Now
they
again
have.
we'll have the other parallel path. Is this not clear?
Um,
Why are we having two parallel paths? So that I have discussed here. So say this is the current,
yes.
this was the input current. So here
Okay.
what was the path?
Yes, from
To
B1,
the
the
green
current
one.
is being
Yes,
splitted into orange and the green.
yes, orange and the green. That is correct. So one orange is the coil one. This what? Which was this?
No,
This
no,
is
from
coil
12 it
12.
is going, sir. From 12th
From
segment
12
only
it
it
is
is going.
going to this, yes, to this, yes, to this 12. The color, yeah, from this 12 it is split, it is getting split between this green and this
Uh,
orange,
Yes,
right?
correct. Yes, sir. Yes.
So let us start from 1. So this is the orange one, so 12. After that, so this is the 12th coil. See, this is brush 1 intercurrent IA is coming. That current is being split into two portions. One is flowing through coil number 12. So first I should make coil 12. This
Yes.
is this one. From coil 12 it comes to commutator segment 1. This segment 1 is nothing but the same as this one. So this
Red
goes into
one.
coil 1.
Yes, sir. Yes, clear, clear.
Then coil 2, then 3, then 4, and then 5. From
Yes.
5, where is 5? This is 5. From 5 it will get connected here, B2, brush 2.
Okay.
It will get connected. Now look at the other path, the green path. Green path is this one. So which coil is this one? This is coil number 11, right? The
Yes.
green one, this is the bottom conductor. Bottom, we have named coils with uh, the top conductor. So top conductor of any coil, whichever slot number it is in, that is the coil number. That is what we have given. So this green is at the bottom. So when this green comes to top, it is in slot number 11. So this is coil number 11. So this is this one. After 11 it comes as downward, then it goes to blue one. Blue one is which one? This is the 10th one, right? This
Yes.
is the 10th
Yes,
one.
sir.
So 11 to 10, then 9, then 8, then 7, then 6, and 6. This is the sixth one. It comes and gets collected here at brush 2. So this completes the two parallel paths. Now are the parallel paths clear?
Yes, sir. Clear, sir.
Okay. Now look at which one of these coils are having some induced EMF. If we look at the flux linkage waveforms, where is that? Yeah. If we look at the flux linkage waveforms,
Sir, this part is also clear, sir. Whichever we have almost maximum or flat, it is zero. And for the
yes,
rising edge, it is a positive maximum.
correct. So in this case, we are having for this rotor position, we are having okay. Again, we have to. Uh, so what was our rotor position here? It is like nothing is in the magnetic neutral axis. But here, okay, we'll discuss this again. We'll discuss this again once more. I'll clearly indicate the time instant so that it is clear. These flux linkage waveforms are the flux linkages of the coils with time, and as the rotor actually rotates in the anti-clockwise direction. So coil 1, so this rotor position whatever is shown here, this indicates this instant.
Yes, correct.
After some time, when this one comes here, then that will be indicated by the next instant, right?
Yes, sir.
After some time, when actually the this coil 1 has come here, like that. So basically when coil 1 is here, something, all the slots have moved by some angle,
Yes,
that's all.
yes.
So at that instance, so that is similar to the case we have discussed, where some
Yes.
conductor is here, no conductor is in the magnetic neutral axis. So we have to take the flux linkage waveforms at that instant and look at which one is having 0, which one is having positive, which one is having the slopes. But a easier way to look at that is, let us look at this only. If a coil is under the stator pole, its flux linkage will start increasing, right? You see 2. 2 is starting to increase here. Just
Sir,
when,
can I make, sir, I'm thinking one point. Can I make that once?
yes, you can make.
Sir, at any instant, it is, I'm thinking that at any instant we are having, from this figure, if we consider, we are having four EMFs are getting added.
At any, not at, that is the point I was trying to make. It is not 4 always, it is sometimes 4, sometimes 5.
Okay. If we think at the zero instant, sir,
Yes.
um, the blue, red,
Yes. Hmm.
pink, and the maroon, I guess, these can
Green
contribute
also.
to the EMF.
Green also, the other green also.
But the other green from the figure, if we see at a zero instant, it is
Hmm.
almost maximum.
But it is similar to this 2 and 6 are similar in some way. 2 is also
Mm,
just rising, after that it was falling just behind. It was rising and stopped rising after that.
okay.
So yeah,
So
so
if that is the
it
case,
matters.
then
That
we.
is why, just a
Oh,
minute. That is why the pole, how big we make, that also matters. If we just
oh,
had made it like this, then it was very clear that all five of them would be contributing to that.
okay.
Right?
Yes.
Now consider it a little bigger one. So it is very clear that all these five are under this pole, and all five of them will be having some induced EMF. That is clear.
Hello.
Oh,
As the
hello, yeah.
rate, as the rate of rise of the EMFs in these five coils is the same, they have equal EMFs which can be added because of they are in parallel, right?
They're in series.
Ah, series, sorry, series. Yes, yes.
So all these coils, the rate of change of flux linkage is the same. So all are having some induced EMFs, which can be considered as constant quantity. It is an approximation. So these slopes are almost, the slope values are almost the same, right? So
Yes,
these five are in series. So I'm simply adding the five induced EMFs. So that makes it 50 volt. So if I consider 10 volt per coil,
yes,
right?
yes, sir.
Now now consider the second one, second type of rotor position. So this is one type of rotor position that we have already considered. So this is one type where no commutation is happening. Can you see that it is the same? Okay, the 12 ones. Here how many did we have? Here also we have 12. Okay, so this is the commutation instance. Sorry, this is the case we are talking where commutation is taking place in coil 1.
Okay.
Right, right. So
Yes.
at this
Yes.
instant, 1 2 3 4 5, they are contributing to induced EMF. Right.
Okay.
Now let us consider this one. Let me zoom it a bit. Here no coil is going through commutation.
Yes, sir. Correct.
Right.
Yes.
So who are in series? 12, 1, 2,
One, two,
3, 4
three,
and 5.
4, 5. Yes.
They are in series.
Yes, sir.
But 12 and 5, they are not under the pole. Even if we make the pole like this, even if we extend the pole like this,
Mm,
12 and 5 are not under the pole. That means
okay.
their flux linkage and that their flux linkages are not changing. That means they
Oh,
have no induced EMF. So the
okay.
induced EMF contribution only comes from 1, 2, 3 and 4. So 4 coils.
Then you say that it will be same as that of earlier case, right?
Same, I did not get your point.
Okay, sir. Okay. Let us continue.
So 40 volt in this case and 50 volt in the other case.
Yes.
So that means there is a ripple, right? Induced
Yes,
EMF
sir.
is
Yes,
not
yes.
constant always. It is sometimes at some rotor position it is 40, at some other rotor position it is
Hmm.
50. It is
Yes,
smoothly
sir.
varying
Yes.
between the 2 points.
Yes,
What
yes.
my next
Correct.
point was is here I have considered only 12 slots. If we
Yes.
increase the number of slots,
Then the ripple will be less.
then the ripple will be less because say this is instant 1 where no conductors are going through commutation, but anyway this red one are not contributing to the induced EMF much because they are not under the pole.
Yes, yes, sir.
These coils are only contributing to the induced EMF.
Yes,
So
correct.
these coils induced EMF contribution are less. So even if after some time one of them goes to commutation or two of them goes to commutation, they rotate and one comes to this position, another comes to this position. Although one of them is shorted, there is no change, no reasonable change in the induced EMF because so earlier it was like say uh, say four of them were coming in series and they were contributing, right?
Yes.
Now say due to commutation this does not come and this does not come, so these are shorted,
Okay.
so only three.
Yes.
But already if this the induced EMF because of this shorted
Is
coil
small.
earlier if it was already low,
Yes, yes.
then it does not make any significant difference.
Yes,
So
sir.
earlier
Correct.
30 volt, so 30 volt, say this was only making some 1 volt earlier,
Yes.
so the ripple is very low. So my point was if we make the number of slots quite high, then the ripple will be negligibly small. So for clarity let me,
Yes, sir. Yes, sir.
because
Sir, I got the point. I
yeah,
got your
yeah,
point.
let me make a clearer picture uh, so that you know the asymmetry that I was talking about. So this is the rotor this is the pole, right? So one case where commutation is going, there is commutation going on. This is one case, right? So how many coils are there? 1 2 3 4 5 6 7 8, so total 16, right? And commutation is going through in these ones. Now the same thing when it will rotate, it is just about symmetry. Do you see the difference? The two cases. In this case, one, first of all, do you understand the two different cases I have drawn?
No, sir, I didn't get.
Okay.
In this
Right.
case, we are getting.
So can you see the vertical and horizontal lines?
Yes, sir. Yes, I am able to see that.
So in the
In
first
sir,
case,
in the first case, the magnetic neutral axis is passing through the coil, whereas in
yes,
second case it is not there.
yes, that's all.
That is the difference I can observe.
Yes, that is the only this difference will cause the ripple in the induced EMF.
Okay.
Don't know why uh, the pen is not working now. Charge is there. So in the first case, can you see how many coils are coming in series? Because the magnetic neutral axis coils, they are shorted. They are not coming in series. So the
Yes.
coils which are on the top, 1, 2, 3, 4, 5, 6, 7. The 7 coils which are coming in series, right?
Yes.
And
Yes, sir.
on the right hand side picture, how many coils are coming in series? 8
One,
coils are
two,
coming in
three, four,
series,
five. Yes. Yes.
right? Can you see
Yes,
that?
sir.
So for one case where commutation is happening, there 7 coils are coming in series. Where commutation is not happening, 8 coils are coming in series. What I am saying is, if you have reasonably high number of slots, then the coils which are not participate, which are going to undergo commutation, I don't know why I am not able to write.
Okay.
The coils which are near, in the right hand side picture, you look at that, the coils which are very near to the magnetic neutral axis, what is
Yes.
their voltage contribution? That is very low.
Yes, sir. Yes.
That is correct. So even if
Yes,
they
sir.
are
Correct. I
shorted,
agree.
there is no significant difference
No
in
much
the induced
difference.
EMF. Yes, that is the point.
Yes, sir. Okay, sir, got it, sir. Sir, I have a request for you, sir, in which you have shown time domain flux linkages, right?
Yes.
It would be better if you can show the all the coils EMFs in the same plot, sir, in the time domain itself.
It will be too clumsy, right?
At
Already
least
I have
at
plotted
yes, sir,
six
at least
ones.
you can have at the bottom. I am saying please include these in two in the same slide so that at every instant we can compute computation of EMF. It would be easier, I guess.
Yeah, I understand that. I have not given because just to, if I include too many plots, then it will it will hamper visibility. You can
Yes,
look
sir.
at the
Yes.
slope. That is all.
Okay,
You
sir.
can look
Okay.
at the slope. Okay.
Okay, sir. Okay.
Okay. So let us stop for today. So we have discussed why induced EMF in armature winding is a constant DC number only. It is not a
Yes, sir.
quasi-square wave. That is the point we tried to reach.
Yes,
Okay.
yes. Thank you, sir.